Graphing rational functions. So we finally are going to put everything together on a graph. So we have discussed domain, holes, vertical asymptotes, horizontal asymptotes, slant asymptotes, x-intercepts, y-intercepts. Extra points is going to be a little new for us. But we're going to put all this together and then actually graph one of these. Let me just get my calculator out and ready to help us. So the procedure is the same thing we've been doing. So we still need to, before we even get to that graph, we want to kind of do a lot of this stuff first. And there's going to be a space up here for showing our work. This is where we'll do our factoring and substituting and stuff like that. Long division if we need to. So let's see, we could factor the numerator to be x minus 3 and x minus 4. And the denominator is x plus 3, x minus 3. X plus 3, x minus 3. Okay. Wait for the calculator to get out of the way. All right. So now I find it best to state what the denominator equals to help me with the domain. So my domain is going to be from negative infinity to negative 3, then between negative 3 and 3, and then also at 3 and infinity. 3 to infinity. All right. Now the x minus 3's will cross out, and that's going to cause that term to be a hole. The term that did not cross out, the x equals negative 3, that's the vertical asymptote, x equals negative 3. And the hole is going to be at positive 3, comma, something. Well, let's figure out what that something is. After we factor this, we can rewrite it as x minus 4 over x plus 3. And that's what we're going to substitute in our whole x value for. So this is our hole right here, and this is our vertical asymptote. So we plug in x equals 3 here. It's going to be 3 minus 4 over 3 plus 3. 3 minus 4 is negative 1. 3 plus 3 is 6. So we're looking at 3 comma negative 1 sixth. All right. Then for the horizontal asymptote, we do a comparison of powers. This is a equal power expression, x squared over x squared. Remember, we always go back to the original when we do horizontal. And so it's an equal power. That means we're going to take the coefficients, which in this case are 1 and 1. So we do have a horizontal asymptote, and it is y equals 1. It is not top-heavy by exactly 1 greater, so there is no slant asymptote, so we have no long division on this problem. All right, then for the x-intercepts and the y-intercepts, this was the most recent thing that we did over here. And remember, all of this, you have these notes for them, but you could always go back and check, x-intercept, you solve the numerator, y-intercept, you plug in zeros. So for the x-intercept, I am solving what is up here, the x minus 4 over x plus 3. So solving the x minus 4 up here, x minus 4 equals 0 is going to be pretty easy. I just get x equals 4. And so that is the x-intercept. Let me scroll down and put that in. That's going to be 4, 0. 4, comma 0. And the y-intercept, I take this expression that I plugged in 3 to get the y value of the whole. Well, this time I plug in 0 to get the x, to get the y value of the y-intercept. So when I plug in 0, I get 0 minus 4 over 0 plus 3 is negative 4 over 3. And so that is the y-intercept, 0 comma negative 4 thirds. All right. So that's everything that we've done so far. Now let's actually put it on the graph. You don't graph the domain, but the domain is the graph. But all this other stuff we're actually going to put down on this graph here. So first, the whole. 3 comma negative 1/6. Now, negative 1/6 is a fraction, so we're going to have to kind of estimate a little bit. But that would be at 3 negative 1/6, and that would be around here. And you actually want to draw a hole, like a circle, a very small little circle. X equals negative 3 is a vertical asymptote, and a vertical asymptote is a dotted or dashed vertical line. So we draw this in like that. The y equals 1 is a horizontal asymptote at 1. Like that. The x-intercept is 4, 0, so I'm going to plot that as a solid point, 4, 0. That would be right around here. And also 0, negative 4/3. 0, negative 4/3 is about here. You could always convert it to a decimal if you think that might be easier. Now, for extra points, what we want to do is type the function into our calculator. Let me go back, scroll up to the original function, and actually type this into our calculator here. So if I go to y equals, and I want to do the whole numerator in parentheses and the whole denominator in parentheses. So parentheses, x squared minus 7x plus 12, close the parentheses, divide, open parentheses, and then put the denominator term x squared minus 9, close parentheses. Zoom. 6 will get us our standard view zoom. And just looking at this a little bit, you can kind of see what's happening. We see that vertical asymptote at x equals negative 3. We see we have a y equals 1 horizontal asymptote. So that kind of also checks our work for us a little bit. We see we're crossing the y-intercept there. The x-intercept is over here. But to get some additional points, I just want to take a look at the table. And on the table, I just want to kind of go from, like, let's say, negative 8 to positive 8, and just see if there's any nice, simple points that I could jot down and use, as a reference here. Because the more points you can add, the easier it's going to be for you to actually draw the graph. So I see I have negative 8, 2.4, negative 5, 4.5. That's a pretty good one. Negative 5, 4.5. Negative 5, comma 4.5. Negative 4, 8. Anything with whole numbers you definitely want to use, or anything 0.5 is good. Negative 2, negative 6. Negative 2, negative 6 is a good one. Notice that at negative 3 it's error, and that's because that's where the vertical asymptote is. So let me scroll down even more. Negative 1, negative 2.5 is a good one. Negative 1, comma, negative 2.5. Then let's see, we got 0, negative 0.133. That's your negative 4/3 is negative 1.3 repeating. 3, again, we have an error because that's where the hole is. 4, 0, that's our x-intercept. So the table also is a good way to kind of confirm a lot of the stuff that you have. And then you see a lot of these points don't really get much further, so it kind of hugs real close to the x-axis after that. Like, let's write just down a 7.3 and make that our last one. So, include as many as you can. I would like you to do probably at least 3 or 4 on an exam, as far as stating them goes. And then plot them. So let's see. Negative 5, 4.5. So 3, negative 5, 3, 4.5 is about here. Negative 4, 8, negative 4. I'm going to need to scroll up a little bit more. So negative 4, 4, 7, 8 is here. And then negative 2, negative 6. So negative 2, negative 6. Negative 1, negative 2.5 is here. And then we're going to have 4, 5, 6, 7.3 is about there. And definitely use the picture on your calculator as a guide on how this thing is supposed to look. And so what I can tell is I can tell that I'm going to have something just real quick. I'll just draw a rough sketch. It's going to be something like that and then like that. But I'm going to use these points as my guide. So this is going to come in and go through these points here. Make sure to never cross the asymptotes. And then the other part of the graph is coming up here. And this is kind of tough to do on a tablet that I'm using right now. All right, but when you get to the hole, you draw it to the hole, then you pick up your pen, and then you continue after the hole. Don't go through the hole because it's a hole in the graph. And you put arrows on the ends, just like that. And that's about it. So that's graphing a rational function. So all the stuff we've been doing as far as stating the domain, the the holes, the asymptotes, the intercepts, you know, it's putting all of that together now. Your domain makes sense. It should anyways, because negative infinity to negative 3, the graph, and then there's a gap. And then from negative 3 to 3, there's the graph, but then we have a gap, that's a hole, and then from 3 on is more of the graph. But putting all this together and having the calculator kind of check our work, showing all this work along the way is how it's done. All right, see ya.